Hi, gang. I am here to teach you about something very exciting, writing equations of lines. My name's Miss Brent. I teach up at the high school. Maybe I have some of your older brothers and sisters. Can't wait to see you when you get up here. Writing equations of lines, guys, is very important because we can use this idea to make predictions about the future. Seriously, it's a wonderful, wonderful tool. You're going to write equations of lines based on real life data. If you go into the math field, you may be tasked with doing that and predicting something that's going to happen in the future. Let's take, for instance, this little graph that I already have for you. Okay, the graph represents how much it will cost to go snow tubing per hour. Ugh, I just can't stand to think that it's winter, but that's all right. I guess it is fun to go sledding. How much will it cost to snow tube for 4 hours? How much will it cost to snow tube for 12 hours? Well, all I have is this graph, and I can't even, it just doesn't go far enough for me. You know, I can't even see after 1 hour what it's going to cost because whoever made this graph, it's not representing what I want it to. Okay. So if I knew the equation of this graph, I could, or if I had a bigger piece of paper, I guess I could extend it and look and see, where that would go. But if I had the equation of the graph, then I could just simply fill in the number of hours I snow tubed, and off would come the answer. Okay? So let's think about it. You only need 2 things to graph the equation of a line, correct? Think about what those 2 things are. Yep, I heard you say it. Slope and y-intercept. Very good. Those are the 2 things you need. So looking at this graph, is there a way we could find the slope and the y-intercept? Since they are so nice to graph this for us, it represents how much it will cost to go snow tubing per hour. Okay, so let's look. The y-intercept is kind of blaring out at me, right? The y-intercept, my line is crossing the y-axis at 4. Or if we want to be technical here, 0, 4. Okay, there's my y-intercept. My slope, well, I'm going to go and count from point to point. I'm going to use this one, okay? And since my x and y axis are both going by the same amount here, you have to be careful when you're counting rise over run that your x-axis is going by the same amount that your y-axis is. Okay, my y-axis is going by halves. 1/2, 1, 1.5, 2, 2.5, 3. My x-axis is going by 1/2, 1, 1.5, 2. So I can just count the units. I go up 1, 2, 3, 4, 5. I go over 2. Somebody else might have counted this way. I go up 1, 2.5, and over 1. Well, 2.5 over 1, that's 5 halves over 1. That's still 5 over 2. Okay, so as long as your x and y axis are using the same scale, then you can just count the units. Okay, so my slope is 5 over 2. In order for me to get from point to point, I just saw that I can go up 5 over 2. Hey, if you don't like counting rise over run, you could always just take the coordinates of this point. What is this? -1, 1.5. Right? -1, 1.5 is this point. This point I know is 0, 4. So I always could just subtract my y coordinates. 4 minus 1.5. Divide by the x coordinates. 0 minus -1. So I get 2.5 over, minus a negative, that's plus 2.5 over 1. Yep, that's 5 over 2. Any way I do it, I get 5 over 2. Okay, so now I have the slope. I have the y-intercept. I can make the equation of this line. It's y equals 5 over, oopsies, 5 over 2x plus 4. That's the equation of this line. Now I have all the power in the world. You tell me how long you want a snow tube, and I'll tell you how much it's going to cost. Well, they told me 4 hours. Great. I'm going to put 4 hours in for X. Multiply it by 5 halves. What's that, 20 halves? So that's 10 plus 4, 14 bucks. You better bring 14 bucks along. You can snow tube for 4 hours. Well, someone wants to spend the entire day there. Wow. Not me. If it was a pool, I would, but not a mountain with snow on it. 12. We're going to put 12 in for X. Okay, I have the equation. I have all the power to find any. You just give me how long you want to stay. I'll tell you how much it's going to cost. Oh, 5 halves times 12. I'm going to do that differently. I'm not just going to multiply across the top. I don't feel like taking 5 times 12. I know that 2 goes into 12 6 times. So anyway, this is 30 plus 4. 30 plus 4. Oh, it's going to cost me 34 bucks if I want to spend, if I want to spend the whole day there. Okay, there we go. 34 bucks. Okay, see what I mean about the power of the equation of the line? This equation will give me any point on this line. And this line, they told me, represents how much it costs to go snow tubing per hour. Okay, so we made a little graph. X was the number of hours. Y's how much it's going to cost. There we go. Okay, so we need to practice this skill. What if I asked you to write the equation of a line with a slope of 1 and passing through the point -2, 3? There are multiple ways to do this, guys. Sometimes if I'm lucky and I have some graph paper, I might just graph it so I can do what I did on the previous page. I'll plot the point -2, 3. Okay, -2, 3. Here's my origin. -2, 3. There's my point. They told me it has a slope of 1. So that means I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Or -1 over -1, that's still a positive 1. So I could go down 1 to the left 1, down 1 to the left 1. You know, I do that so that I can make as many times as I want so I can make a straight line. No problem. I already had the slope. They told me it was 1. So I have y equals 1x. I just needed the y-intercept, and I just kind of used my graph to find that. What is it here? 1, 2, 3, 4, 5. So the equation is y equals x plus 5. Okay? Now, what if I don't have a graph? Well, if you didn't have the graph, or maybe you're just sloppy like I am and you don't trust your graphing to make sure you have the right y-intercept, you can just write what you know, okay? I know that it's y equals 1x plus b. I'm assuming you guys have learned y equals mx plus b as the equation, the slope-intercept form of a line. M's the slope, b's the y-intercept. Anyway, so I have y equals 1x plus b. I know my slope's 1. I don't know my b. Well, I do have an xy point. So wherever there's y, I'm going to write 3. Wherever there's an x, I'm going to write -2. And now I just have a simple one-step equation that I'm going to solve. And that will tell me that b is 5. Looks like I found one I graphed. Sorry for that. I'm at the high school making this, and Mr. Black just came on the loudspeaker. Anyway, I got b to be 5. So then I would write, I knew the slope was 1. So I would say, oh, y equals 1x plus 5. Of course, we don't write 1x. We just write x. That's not something that's proper now that we're in Algebra 2. Okay? So that gives you y equals 1x plus 5. Okay? Next way to do this, there's another little formula that's used often in calculus. So those of you that are interested in perhaps pursuing that, you want to know this form. It's called point slope form. You take y minus the y coordinate of one of your points. That has to equal the slope times x minus one of your x coordinates. Okay? And that x1, y1 is a point on the graph. Okay? You take y minus the y coordinate of the point equals slope times x minus the x coordinate of the point. Alrighty? So, I know the point is negative 2, 3. So I'm going to write y minus 3, because that's my y coordinate, equals slope. Well, they told me slope. It was 1 times x minus the x coordinate of the point, which happens to be negative 2. All right, so when you subtract a negative, of course, we write that as addition. I'm going to distribute my 1 through here. So I have y minus 3 equals 1x plus 2. And then I'm going to add 3 to both sides. And that's going to give me y equals x plus 5. Ta-da! I got y equals x plus 5 every way I did it. Another one of the joys of math. Multiple ways to solve a problem. Whichever one of these hits you, do it. Okay? Whichever way you like, you just do it. Sometimes we just know 2 points and we just have no piece of graph paper at all. Doesn't change the fact that I need my 2 things. Slope and y-intercept. That's what I need. Well, I have these 2 points, so I guess the only option is to find the slope by subtracting the y's. On top, subtract the x's in that same order. Since I did 4 minus negative 5 on top, I'm going to do negative 4 minus 2 on the bottom. That gives me 9 over negative 6. I'm going to reduce that by dividing each by 3. It's 3 over negative 2. Somebody else might have found the slope the other way. Maybe they started with negative 5 and they subtracted 4, and then they would have to start with 2 and subtract negative 4. So they would have gotten negative 9 over positive 6. Well, guess what? That's still negative 3/2 any way you look at it. Okay, find the slope. You don't have to worry so much about which one's y2, which one's x2, which one's y1, which one. Just start with 1 point, subtract the y's, and then start with that corresponding x and subtract the x's. All right, so I have my slope is negative 3/2. Fantastic. Slope's negative 3/2. I need the y-intercept. So I have multiple ways to do this. I can just say y equals negative 3/2 x plus b. And I can pick one of the points. I'll just pick this because it's staring at me first. The y coordinate is 4. The x coordinate is negative 4. I'm trying to find out b. When I multiply negative 3/2 times negative 4, I get 12 over 2, which is 6. So it's going to look like b is negative 2. 4 minus 6. So my answer, y equals negative 3/2 x minus 2. Somebody else might have said, well, I did that, but I guess I did it wrong because I picked this point. No, of course you didn't do it wrong. You put negative 5 in for y. You put 2 in for x. And you got negative 5. What would that be? Negative 6 over 2. That's negative 3 plus b. I'm going to add 3 to negative 5. Well, I got negative 2 to be b too. You're fine. Somebody else is like, well, I wanted to do it that calculus way that she taught me because I'm going into calculus. Great. Then you did y minus, let's pick this one, y minus 4 equals slope times x minus negative 4. So you got y minus 4 equals negative 3/2 x. What would that be? Minus 6, right? Negative 3/2 times 4 is minus 6. I'm going to add 4 to my negative 6. Oh my goodness, I got y equals negative 3/2 x minus 2. There's a shocker. Okay? and somebody else, of course, the last way is to do y minus